What I saw was the plane coming down. There was some sparks as the undercarriage or the bottom of the plane actually sort of touched the runway.
We were landing. I was looking through the window and I saw there, I don't know whether the landing gear crashed or have a problem, but it was broken. I saw the engine on the tarmac and, everything was so quick.
January 2008. A British Airways Boeing 777, a marvel of modern aviation, is en route from Beijing to London. Known as the gold standard of commercial airliners, the 777 has an impeccable safety record, logging millions of flights without a single major accident. Passengers settle in for the 10.5-hour journey, unaware that they are about to become part of aviation history. As the aircraft approaches London's Heathrow Airport, everything seems routine. The pilots prepare for a smooth landing on runway 27 left. But just 1,200 feet above the ground, disaster strikes. The engines, powerful and reliable, fail to respond. Thrust levels plummet, and the plane begins losing altitude rapidly. The pilots, faced with the unthinkable, have mere seconds to react. This is the story of British Airways Flight 38.
A spokesman for Heathrow Airport described what happened at just after 20 to 1 today as an emergency landing by a Boeing 777, British Airways Flight BA38 from Beijing.
A flight that came terrifyingly close to catastrophe and revealed a hidden vulnerability in one of the world's most advanced aircraft. British Airways Flight 38, a Boeing 777, took off from Beijing on January 17, 2008. This long-haul flight, bound for London's Heathrow Airport, was piloted by Captain Peter Burkhill and First Officer John Coward, both seasoned aviators with thousands of flight hours between them. The flight was one they had completed many times before, and the crew anticipated an uneventful journey. On board were 152 passengers, ranging from business travelers to vacationers eager to return home. Among them was Nick Harris, looking forward to an early arrival and reuniting with his family. For everyone on board, it was just another routine flight. The Boeing 777, equipped with 2 Rolls-Royce Trent 800 engines, was considered one of the safest planes in the world. Its modern design and advanced systems made it the flagship of British Airways' fleet. The journey from Beijing to London involved crossing the frigid expanses of Siberia and cruising through some of the coldest air masses in the atmosphere. While temperatures outside the aircraft plummeted to as low as -74 degrees Celsius, the pilots monitored the fuel temperature gauge carefully, as standard procedure dictated. For most of the flight, the autopilot handled the controls, maintaining a steady altitude and speed. The engines hummed smoothly, and the crew carried out routine checks, confident that the advanced systems of the 777 would ensure a safe and efficient flight. As the plane approached its destination, the anticipation of landing at one of the world's busiest airports began to build. Passengers prepared for arrival, glancing out of the windows as the city of London came into view. Unbeknownst to them, the next few moments would forever change their lives. Without warning, the engines failed to respond to the crew's commands for increased thrust. The once reliable jet was suddenly crippled, and a race against time began. As Flight 38 neared Heathrow, it entered the final stages of its approach.
As British Airways flight and cabin crew, we are trained on a regular basis to deal with emergency situations. We have procedures to follow and everyone knows their role. Flying is about teamwork.
The crew aligned the aircraft with runway 27 left, anticipating a smooth landing. Turbulence buffeted the plane, but this was not unusual. The autopilot adjusted for the gusts, maintaining stability as the jet descended. At 1,200 feet above the ground, First Officer John Coward took manual control of the aircraft. following standard protocol for landings. Everything seemed routine. Captain Peter Burkhill glanced out the window, noting the airport facilities below, while Coward focused on the descent. With only 2 minutes to go, air traffic control cleared the plane for landing. At 720 feet, disaster struck. Coward attempted to increase engine power to compensate for the descent and turbulence, but the engines failed to respond. The throttles moved, but there was no surge of power. Confused, he repeated the action, yet the engines remained at idle. "Pete, I can't get power on the engines," Coward exclaimed. The plane's speed plummeted, and the alarms began to sound. Burkhill quickly assessed the instruments and confirmed the grim reality. Both engines were unresponsive. They were experiencing a catastrophic double-engine rollback, a scenario so rare that it was barely covered in training. Without power, the plane began to fall rapidly, unable to maintain its glide path. Below them lay the densely populated London suburb of Hounslow, with its tightly packed houses and a busy motorway. The prospect of crashing into buildings or traffic loomed large. Captain Burkhill, faced with the gravity of the situation, knew they had mere seconds to act. Coward focused intently on keeping the plane level, despite its diminishing speed. Burkhill, thinking quickly, decided against retracting the landing gear.
Less than a minute from landing, both engines suddenly rolled back and refused to accelerate. With only seconds to act, the pilots worked together to extend their glide just far enough to avoid a series of potentially deadly obstacles.
Although the gear created drag, it would absorb some of the impact in a crash, potentially saving lives. Meanwhile, inside the cabin, passengers remained unaware of the unfolding crisis. They anticipated the usual jolt of landing, unaware that Flight 38 was seconds away from disaster. With Flight 38 rapidly losing altitude, Captain Burkhill knew he had one final decision to make. The plane was just seconds from impact, and their current descent path put them dangerously close to a busy road and nearby buildings. Burkhill realized that reducing drag could buy them crucial distance. "I needed to raise the flaps," he later explained. Retracting the flaps would reduce drag, but also sacrifice lift, causing the plane to descend even faster. It was a risky gamble, but one that could help clear the buildings ahead. Without hesitation, he pulled the lever, raising the flaps from 30 to 25 degrees. The effect was immediate. The aircraft's speed increased slightly, and it managed to clear the rooftops of Hounslow. However, the maneuver left them with no room to spare. The engines, still unresponsive, left the Boeing 777, a glider, hurtling toward the ground at an unforgiving rate. Burkhill and Coward worked together seamlessly, steering the plane toward a narrow strip of grass just short of runway 27 left. The alternative, crashing into the antennas or tarmac, would almost certainly result in fatalities. At just 200 feet, Burkhill made his final call: brace for impact. The landing gear hit the soft ground first, tearing through the soil as the aircraft skidded forward. The impact jolted passengers and crew violently, sending luggage and debris flying through the cabin. Miraculously, the plane stopped just before reaching the busy A30 motorway. Despite the harrowing crash, there was no fire, an extraordinary outcome given the damage sustained by the engines and fuel tanks. The quick thinking and coordination of the flight crew had averted what could have been a catastrophic disaster. As the aircraft came to a halt, Burkhill wasted no time. His instincts as a captain kicked in, and he began organizing the evacuation, ensuring the safety of every person on board. Flight 38 had crashed, but against all odds.
We've had an aircraft crash on the threshold of 27 left. We need to switch everything to 27 right,
okay,
and then stop things coming in for the time being.
Okay.
Most of its passengers and crew would walk away alive. The moment the Boeing 777 came to a halt, Captain Burkhill ordered an immediate evacuation. Despite the shock of the crash, the crew maintained their composure, guiding passengers to the exits. "Evacuate! Evacuate!" rang through the cabin as flight attendants quickly sprang into action, deploying the emergency slides. Passengers scrambled to unbuckle their seatbelts, many shaken but miraculously unharmed. Outside, the frigid January air was a stark contrast to the chaos within. Smoke and the smell of jet fuel filled the atmosphere, heightening the urgency to get everyone off the aircraft. The greatest danger now was fire. A single spark could ignite the fuel leaking from the ruptured engines. One by one, passengers slid down the inflatable chutes, many leaving behind personal belongings in their rush to escape. "Duck and jump!" flight attendants yelled, ensuring the evacuation proceeded as swiftly as possible. Among the evacuees was Nick Harris, who later described the surreal experience of sliding onto the muddy field, clutching nothing but the clothes on his back. Meanwhile, Burkhill and his co-pilot, John Coward, conducted a final sweep of the cabin. They checked every row to ensure no one was left behind. The cockpit door, now warped from the impact, was a grim reminder of just how close they had come to disaster. Outside, emergency responders arrived within minutes. Fire trucks and ambulances formed a line near the crash site, ready to assist. The flight crew, still in shock but determined to see their job through, helped paramedics tend to the injured. Of the 152 people on board, 47 sustained minor injuries.
Passengers had all been evacuated, 3 people were treated for minor injuries. The airport's southern runway had been closed, but its northern runway remained open.
But remarkably, there were no fatalities. As the wreckage loomed behind them, the passengers and crew began to grasp the magnitude of what had happened. The engines, once the heart of the technologically advanced 777, now lay in pieces, half buried in the soft ground. Debris scattered the field, a grim reminder of the aircraft's final moments. Despite the damage, the controlled landing had saved lives. Burkhill's calm and calculated actions, coupled with Coward's steady piloting, had turned a catastrophic failure into a survivable crash. The immediate aftermath was chaotic, but the quick response of the crew and emergency services prevented further tragedy. The focus now shifted to understanding what had gone so catastrophically wrong. Why had both engines failed at the most critical moment? For investigators, the search for answers was just beginning. In the hours following the crash, the scene at Heathrow was a flurry of activity. Investigators from the Air Accidents Investigation Branch, AAIB, arrived promptly, armed with tools to uncover the cause of British Airways Flight 38's harrowing descent. The Boeing 777, once a symbol of technological precision, now lay broken and scarred, just short of the runway. From the outset, the investigation posed a unique challenge. Unlike other aviation disasters, the wreckage of Flight 38 provided no immediate clues.
The plane did come to a halt reasonably quickly.
Well, I was driving on the road running parallel to the runway, stopped at a set of traffic lights, and then as we pulled away I saw this plane come to an abrupt end at the end of the runway and sort of turn about 90 degrees.
The engines were intact, the fuel tanks were full, and the flight crew reported no mechanical malfunctions during their approach. Yet, the jet had lost power at the worst possible moment. The investigation team meticulously examined the aircraft's remains, searching for signs of damage or failure. The landing gear was found pushed up through the wings, and the nose gear had collapsed on impact. However, there was no evidence of fire or catastrophic structural failure that could explain the loss of power. One of the first steps was to recover the flight data recorders, the black boxes. These devices would reveal critical information about the aircraft's final moments, including speed, altitude, and engine performance. The Quick Access Recorder, QAR, An additional data logging device was also retrieved. Investigators were confident that these tools would provide the answers they needed. Yet, the data revealed an unsettling mystery. 45 seconds before impact, the engines had entered what is known as a rollback, a condition where they failed to produce enough thrust despite the crew's commands. The auto-throttle system had attempted to increase power, but the engines didn't respond. Early speculation pointed to possible fuel starvation, a rare but not unprecedented issue. However, a thorough inspection of the fuel system quickly ruled this out. The tanks were full, and the fuel itself showed no signs of contamination or waxing, a condition that occurs when fuel becomes too cold and thick to flow properly. The investigators then turned their attention to the engines, Rolls-Royce Trent 8s, renowned for their reliability. Detailed inspections found no evidence of internal damage or malfunction. It was as if the engines had simply stopped working, defying all logic and engineering standards. As the days turned into weeks, frustration grew among the investigation team. They had access to an intact aircraft, complete flight data, and the testimony of experienced pilots. Yet the cause of the double-engine failure remained elusive. For the aviation industry, this was an alarming development. The Boeing 777 had been a gold standard in safety, with no history of major accidents. If the cause couldn't be identified, it could undermine confidence in the aircraft and its systems. Pressure mounted to find answers quickly. Investigators began to analyze every detail of Flight 38's journey, from its departure in Beijing to its final approach at Heathrow. They examined weather conditions, fuel flow rates, and even minor anomalies in engine performance. The hope was that a seemingly insignificant detail might provide the breakthrough they needed. But as days passed, the mystery only deepened. Flight 38 had become one of aviation's most perplexing cases. To uncover the truth, investigators would need to push the boundaries of their expertise and revisit their assumptions. Whatever had caused this near tragedy was not going to reveal itself easily. Months into the investigation, the AAIB team faced an unprecedented challenge. Flight 38 had landed with all major systems intact, leaving no obvious explanation for the double-engine rollback. As frustration grew, the team began revisiting every piece of data and detail, no matter how small. That's when a new theory began to take shape: ice. Investigators knew that modern jet engines are built to handle low temperatures during long-haul flights. Fuel, which cools significantly at high altitudes, can sometimes form tiny ice crystals. However, these crystals are typically harmless, as they dissolve when passing through heated components like the fuel oil heat exchanger, FO. But could ice have played a role in blocking fuel flow on Flight 38? To test this theory, engineers at Boeing's facilities in Seattle recreated the flight's conditions. They simulated the long, cold journey over Siberia, where temperatures had plummeted to -74 degrees Celsius. Over several hours, they observed how ice crystals could gradually build up inside the fuel lines. What they discovered was surprising. At certain temperatures between -20 degrees Celsius and 8 degrees Celsius, ice could transition into a slushy, sticky state. This sticky range allowed ice to accumulate along the walls of the fuel lines. The prolonged cruise phase of Flight 38 had created the perfect conditions for ice to form and cling to the pipes. But how could this ice cause both engines to lose power simultaneously? The answer lay in the FOHE, a critical component that heats the fuel before it reaches the engines. Investigators found that the FOHE's design included tiny protrusions just millimeters high that prevented the ice from fully melting. During the final approach, when the engines demanded a sudden increase in power, the built-up ice broke loose and surged toward the FOHE. the FOHE became partially blocked, restricting the flow of fuel to the engines. This explained the rollback. The engines weren't receiving enough fuel to generate thrust, even though the valves were fully open. For the first time, the pieces of the puzzle began to fit together. However, the team needed definitive proof. After months of rigorous testing, a breakthrough finally came. During a simulation designed to replicate Flight 38's descent, the sudden surge in fuel flow caused ice to dislodge and block the FOHE. The result mirrored the conditions on the day of the crash: a sudden and simultaneous loss of power in both engines. The culprit had been found: ice buildup in the fuel system, exacerbated by a flaw in the FOHE design. It was a chilling discovery, both figuratively and literally. While the FOHE was designed to prevent icing, it had inadvertently become a weak point under certain rare conditions. This revelation sent shockwaves through the aviation industry. The Boeing 777 had been hailed as one of the safest aircraft ever built, yet it harbored a hidden vulnerability that had gone undetected for over a decade. Airlines and regulators worldwide now faced a critical question: how many other aircraft were at risk? The investigation's findings led to urgent action. Rolls-Royce, the engine manufacturer, quickly redesigned the FOHE to eliminate the tiny protrusions that allowed ice to accumulate. Boeing issued safety directives to operators of the 777, requiring inspections and retrofits of the fuel systems. The ice hypothesis not only solved the mystery of Flight 38, but also highlighted the importance of continual innovation in aviation safety. With the redesigned FOHE in place, the risk of a similar incident was significantly reduced, ensuring that the lessons of Flight 38 would never be forgotten. The crash of British Airways Flight 38 marked a turning point in aviation safety. Though the incident was harrowing, the survival of all 152 people on board was nothing short of miraculous, thanks to the skillful handling of the emergency by Captain Peter Burkhill and First Officer John Coward. But the legacy of this event extends far beyond the remarkable actions of its crew. The investigation into Flight 38 revealed a hidden vulnerability in the Boeing 777's fuel system. The redesign of the fuel oil heat exchanger, FOHE, was a critical outcome, ensuring that ice buildup could no longer obstruct the flow of fuel to the engines. This modification became mandatory for all Rolls-Royce-powered Boeing 777s, providing a safeguard against similar incidents. The Flight 38 incident highlighted the importance of pilot training for rare, high-stress situations. Although the crew's quick thinking likely prevented a far worse outcome, aviation authorities implemented new training protocols focused on engine rollback scenarios and fuel system malfunctions. Pilots now undergo more rigorous simulations to prepare for sudden power loss during critical flight phases, like takeoff and landing. The findings from the investigation led to broader changes in international aviation safety standards. Regulators, including the FAA and EASA, required all airlines to improve monitoring of fuel systems on long-haul flights. These changes reduced the likelihood of undetected ice buildup, ensuring safer skies for millions of passengers. Captain Burkhill and First Officer Coward received widespread recognition for their professionalism and composure during the crisis. Both were awarded the British Airways Safety Medal, the company's highest honor, for their exemplary handling of the emergency. Their ability to remain calm under pressure and make critical decisions within seconds saved lives and underscored the vital role of pilot training and experience. The discovery of ice formation in the sticky range not only affected the 777, but prompted the aviation industry to reevaluate fuel systems across multiple aircraft types. Manufacturers began redesigning components to account for extreme conditions, further advancing the science of aviation safety. The Flight 38 incident served as a stark reminder that even the most advanced aircraft are not immune to unexpected challenges. It demonstrated the importance of relentless vigilance in identifying and addressing potential risks, no matter how rare or improbable they may seem. Today, the lessons from Flight 38 continue to inspire advancements in aviation technology and safety. From real-time data monitoring to more resilient engine systems, the industry has made significant strides in ensuring that such incidents remain exceedingly rare. The story of British Airways Flight 38 is one of both caution and hope. It serves as a powerful reminder that even in moments of great peril, human resilience and determination can prevail. While the crash left an indelible mark on aviation history, its legacy has made the skies safer for generations to come. The triumph of survival and the progress born from this tragedy stand as a testament to the unwavering commitment to safety that defines modern aviation.